this is not number one. All right? Number two is called grouping. The first clue about grouping is, are there four terms? If there's not, skip step 2 and we'll go to step 3, which we haven't started yet. Everybody with me there? That's a real quick test. The main one. Are there four terms? And you should think, now don't assume this, but you ought to think, if it has four terms, we're learning how to do grouping, it'll probably be grouping. But there's we can find out if it is or isn't. You see what it says next? It says, split the problem in two, but you're not just splitting it. It might be written, I think most of them will be written this way, but you want to find the common letter, so just split it in two. There's the common letter there. So we do the greatest common factor. Now, I think this is a key step. When you get this x plus y in parentheses, write it over here and see if you can do another greatest common factor with that x plus y, and we can. If you can't, you just stop, and that's the answer. Let me repeat that. If you can't get an x plus y here out of this with something out here, I don't care what that is, then you can just stop and say that's the answer, but obviously we did. Then it says, do a third greatest common factor. You see, it's like my hand could be one letter right there and right there, so we just take that letter out, times w plus z. And what we've just done is reverse, what word? Sort of, but it's more specific, something we've done. Isn't it just FOIL? Look at it. Isn't this FOIL? And how many times do you multiply with FOIL? 4. It's just reverse FOIL. That's all number 2 is. All right, that's called grouping. We'll do some more of those. Okay. Let's look at the third one. I sort of think this is the easiest one to look at and recognize. Or no, I don't mean that. It's the easiest one to get the answer when you recognize it. That's probably a better way of putting it. And number 3 is called the difference of two squares. Now, it looks sort of complicated, but it's not. I just wrote things out that you'll do quickly in your head. And we've actually done a couple of these, but let's look at this one. Now, here's what we're trying to do right now. We're not trying to come up with the answer right away. We're trying to say, is this, well, let's go ahead and factor it. Number 1, is there a DCF? There's no number and there's no letter. So number 1 is out. See how quick you can do number 1? Just do it quickly in your head. Number 2, are there 4 terms? No, we've done number 2. Now we're down to number 3. Obviously it's going to be number 3 because that's what we're learning how to do. But let's check it out. 4 things. You can do them quickly. Is it a binomial? Yes, 2 terms. Is there a subtraction sign between them? Yes, it must have a subtraction sign. I'll show you why here in just a second. And is the first term a perfect square? Raise your hand if you understand what I mean when I say perfect square. 2 times 2, 4 is a perfect square. 9 times 9, 81 is a perfect square. Is 49 a perfect square? Yes. Is x squared a perfect square? Yes, x times x. It meets the conditions of all 4 of those, so we just factor it. X and x, 7 and 7, plus and minus, and we're done. Pretty easy. And Now let's do FOIL there. The first two, the outside two, the inside two, and the last two. And you see what happens all the time, that drops out. And this one, see, what are you going to do? X, if you put a plus and a plus, you get x squared plus 7x plus 7x plus 49. You get 14x in the middle. If you put a minus, you get a minus 14x for both. If you put a plus and a minus, you get nothing in the middle, but you get a minus sign. So you can't factor that. That's the difference of two squares. Now, so just factor these real quickly on your paper. X squared minus a squared. Is that number 3? Is what you ask yourself first. Is it a binomial? Yes. Is there a subtraction sign? Yes. X squared and a squared are perfect squares, so it should factor quickly into x plus a, x minus a. Right? What about 4x squared minus 81? Let's see, we start out, there's no greatest common factor with 4 and 81, no letter, so number 1 is out, it's not 4 terms, so we're at number 3. A binomial, subtraction sign, is 4x squared a perfect square? Yes. 2x. And 8? It is not, so that's, oh, 81 is, it's not, sorry, that's not an 8. And there's your answer. But this one. And it's not because it is a binomial subtraction sign, but 2 is not a perfect square. 1 times 1. Okay, so that would not work. Okay. So you ought to be able to almost look at a problem and tell. I think step number 3, if you recognize it is 3, it's the easiest by far to put the factors down. They might go a to the second minus 100, and we put a and a, 10 and 10, plus and minus. Try that one. If you can get that one, we're moving on. If you don't get it, we're still moving on. Okay, so it's 2 terms. There's a subtraction sign. Is 25x to the 4th a perfect square? Yes, it is. It's 5x squared and 5x squared. And y to the 10th, isn't any even number here on a power going to be a perfect square? Because it's going to be y to the 5th and y to the 5th. If it's odd there, it won't be a perfect square on an exponent. And there's your answer. Everybody got that? Okay? That's step 3. Now, let's, just to make sure we get them of what I'm looking for, let's turn in the book to page 341.